Hello and welcome to Carbon Removal Newsroom. I'm Ross Kenyon, lead strategist with the Nori Carbon Removal Marketplace. Today I have with me Roland Dittmeyer, a professor at the Karlsruhe Institute of Technology in Germany. I read a Wired article recently called "What If Air Conditioners Could Help Save the Planet Instead of Destroying It?" Great title for an article. I was super intrigued by this. Roland, could you run us through what was covered in this story, which you were mentioned in, and they were discussing your work?
First of all, Ross, thank you for having me here. Yes, of course, I can go through the story a little bit. The basis for that story was a paper we wrote for Nature Communications. And that's in the end about the idea to combine ventilation and air conditioning systems with direct air capture. And there's basically two reasons for that. One is that the amount of air that you circulate in these systems is very large. So it's huge. 10% of the total electricity consumption globally goes into these systems. So even though the concentration is quite low of carbon dioxide, the amount of CO2 you contact is very high. And that's, of course, important to make an impact if you want to produce chemical energy carriers from this carbon dioxide. So that's one point. And the second point is that if you then capture it, if you have the CO2 in your hands, it would be very elegant if you can convert it on site into a easily transportable and storable fuel, because for the during the synthesis, you generate heat. That's the reaction heat. And this heat can be used to improve the energy balance of the direct air capture. So if you combine it, you have this synergy. And that's the second point that motivated us to propose this.
Yeah, it's a far out idea in a good way. I think it definitely caught my eye as something that seemed clever, using this waste heat in this way. What is crowd oil? And are we going to be hearing more about crowd oil as time goes on?
Well, crowd oil alludes to the idea that these will be smaller units compared to conventional petrochemical or chemical engineering big plants. And they will be operated by different people or institutions. In the extreme case, by individuals. And that means if we can offer a technology solution that does that, we would reach out to many people in society, and that's the crowd aspect. And then, of course, we chose this because crowd and crude is very similar.
Yeah, it's a funny little play on words there.
So that's the idea. We would not rely only on big companies doing something. We could mobilize eventually more people, and in this way generate momentum in the uptake of air capture and renewable energy and so on.
Yeah, so one other interesting thing that I saw in the article is that David Keith commented, he's from Carbon Engineering, a very large direct air capture facility in British Columbia, was saying that something akin to, you need economies of scale. You need large industrial organization doing this. It can't just be small little mom and pop direct air capture. You actually need the price to go down that comes from just having like an assembly line kind of mentality with direct air capture. And this crowd oil idea seems like it's the opposite, where you're saying that distributed systems are very important. They're more flexible. They're less vulnerable to a centralized point of failure. But it's possible it isn't as cheap in the long run. I don't really know where the tech will go. But it seems like at least there is a paradigm fight over whether this will be economies of scale and big industrial organizations, or it will be distributed when it comes to direct air capture. Would you say that's a fair summation?
Yes, I think so. I can imagine both, of course. I'm a chemical engineer, so I'm familiar with big plants and I know very well the economy of scale. But here, the idea is like, for example, Climeworks is also doing it. We think of producing those units like cars, of course, with the industrial production facilities that you need for that. So you have to standardize, you just replicate the systems. And in that way, you can at least work on a different economy of scale curve. you will also have the problem that if the unit becomes too small, so the effort for making a little bit of fuel is then prohibitively large. But I think there is quite a region in between those typical petrochemical or chemical huge plants and the tiny systems. And I think personally that fits very well with a current trend we can observe also in chemical industry, more in the fine chemicals area. That's called modular plants. Because these modular plants can also more easily be reconfigured, can be upgraded, you can replace certain modules with better ones. And this is all easier if you follow this concept. So it's a new direction, that's true. And cost is an issue, but it's like producing cars and using, let's say, this kind of equipment probably is the most difficult thing is that then you have a chemical factory. You have to provide, of course, safe operation. And that's probably the biggest challenge we have to face here.
Yeah, I like your explanation. I think mine might have been confusing because I was using assembly line mentality to describe like large scale economy of scale, when actually you might see that same phenomenon taking place in a more distributed model with, hundreds and thousands or millions of tiny direct air capture systems being built, and through standardization, achieving a similar economy of scale. It's just distributed rather than one large refinery or plant.
Yes. So of course, you have some effort for the controls. That's true. But here the point is, if you combine it with the ventilation system, there you also have a control system. So it might be just more economic having this functional integration.
Yeah, and I think it's a very neat way to do it too. I love whenever systems take a waste product and find a way to turn that into value. I think that's very clever. I know people are oftentimes quite hard on enhanced oil recovery and CO2 being used that way, and I totally understand. But I think we're just starting now to see the value that we can actually bring to carbon dioxide and other perceived waste materials or waste heat. I read something about how much waste heat actually escapes around the world. Is it not the bulk of the joules that are used in human enterprise? It's something enormous.
Yeah, that's enormous, yeah. So it's this process integration we go after.
Yes. Well, I know that the building that they mentioned that's in Frankfurt, is that something that will there be stuff happening that's similar to your model of covering the building with solar panels, turning maybe the windows into solar panels, and having air conditioning units that are practicing direct air capture? Is that something that we might be able to see in the next couple of years?
Well, the cases we selected in this paper were just arbitrarily chosen. One category, of course, in my opinion, is the office buildings, big office buildings, because they use a lot of ventilation. And I just selected the Frankfurt Fair Tower because it's a nice landmark building in Frankfurt. I've been living and working in Frankfurt for 11 years, so I know it. But there's not a concrete plan to do it there. What we will do it in our institute in the next 2 years. We also have a ventilation system for our chemical labs. And we work on this technology anyway on the conversion. And we will build it here in this institute to make a first experimental showcase where according to the estimates, we could have about 50 liters per day from this particular unit we have here. 50 liters liquid fuel. So that's not much. That refers to about 36,000 cubic meters per hour of air that goes through this system.
This might be a bit beyond the podcast, but I'm curious why there is a lot of attention in Germany and with Swiss Germans as well with direct air capture. I guess, I think of Climeworks, I think of Klaus Lochner. I'm sure you know a number of colleagues that work with you who are leading the field. Why do German speakers have such an interest in direct air capture? Or is this just purely coincidental?
I think it's coincidental. That's my observation. Most people in Germany would rather argue that it's better to use higher concentrated CO2 effluents, like from combustion or from industrial processes. There are some also quite large sources from the chemical industry that you could use, of course. But in the long term, these if these will go down, of course. So there will not be much combustion in power stations. So it's more convincing, in my opinion, to follow this circular approach, take it from the air. Also because then the standardization is easier. The air is more or less the same everywhere. And if you want to collect the CO2 from a certain effluent, usually you have to do some specific development, because in this source, then there are some contaminants that might be difficult for your process. So that's I would say most people here do not have direct air capture as their favorite.
Yeah, that's probably true of the United States as well. But how it goes, I'm sure its day will come. It seems that not a week goes by that I don't see direct air capture in some high-profile newspaper or magazine. It's still kind of being written about in this science fiction kind of way that you alluded to earlier, but at least they're talking about it. And it seems like it will continue to get more attention and development. And I think we'll continue to see a lot of progress in this field.
Yeah. One week ago, there was an announcement by actually a group of companies to make a study and build a plant that converts CO2 from air into kerosene in the Netherlands, in Rotterdam and The Hague harbor, to produce kerosene there and use it for the airport of Schiphol in Amsterdam. So that's a group of companies that want to build a 1,000 liter per day exemplary demonstration plant in the next, I don't know how many years. So it's moving, in my opinion.
Yeah, absolutely. There's a lot being done on, at the very least, using direct air capture as a sort of carbon capture and use rather than storage. It's maybe not carbon negative always, but it's at least using carbon in a more intensive way before it's being released. But I see those as all stepping stones to a future where much more carbon dioxide is actually being sequestered when it's pulled out rather than immediately turned around and burned again or used. But yeah, I think all of those examples you named and we've discussed are very exciting. And I sort of want to let 1,000 flowers bloom on that. Let's see 1,000 direct air capture companies figuring this out.
Yeah.
Well, Roland, thank you so much for being here. That was instructive. I hope the audience enjoyed it. I sure did. If they would like to keep up with your work, what might be a good way to do so?
Well, you can follow our institute's activities here or at KIT. There are more people working in the field of synthetic fuels. And that would be one reasonable way to do that. Or invite me a second time.
Wait, what was that?
Yeah. You can also come for a visit.
Oh, thank you. That sounds like that's close to the German Spa region, right?
Yeah, it's actually a nice region at the border to France and Switzerland, and is also not very far. But I mean, distances are shorter here anyway than compared to the US. But it's a nice spot. One of the warmest parts in Germany.
If you'd like to walk the Black Forest with Roland Dittmeyer, you can send me a message. No, don't just try to get a vacation out of this. You can reach me though at a podcast at nori.com. If you like this show, give it a great rating and review in iTunes or Apple Podcasts. I would very much appreciate it. And thank you again, Roland. That was a lot of fun. And thanks for teaching us.
Thank you, Ross. Bye-bye.